Hi folks, welcome back. So in the previous video, we saw what is supervised machine learning classification. Now we will talk about regression. Now again, you might ask, but what is regression, right? Regression is nothing but a statistical technique that relates a dependent variable to an independent variable. Now you might ask, but hey, what is dependent variable? What is independent variable? This is all very confusing. I'll take a very simple example. If you say y is equal to 2x, right? We all would have learned this sometime in algebra during our childhood days, like y is 2x plus 1 or something. For the moment, I'll just say y is equal to 2x, right? So here x is an independent variable, right? So this is an independent variable and y is a dependent variable. Now you might ask, but why is y dependent variable? Yes, because the value of y will change as I change the value of x, right? So if I put x as 2, then y becomes 4. If I put x as, say, x is 2, and if I put x as 3, then it becomes 6. As simple as that, right? So if the value of x is 3, then the value of y becomes 6. So it means my y is actually the independent variable. And remember, the independent variable always goes on the x-axis and the dependent variable goes on the y-axis. And normally you would always plot the graph, something like a scatter graph we call it, and you can see, and these are all the different data points, right? So let's take a look. What is regression analysis? So regression analysis predicts a continuous output, right? Dependent variable. So you are continuously trying to find out your dependent variable. You're continuously trying to find out the value of y based on one or more predictor, which is the independent variable, right? Pretty simple, right? Now, again, if I take an example of house price prediction, right? So here, if you see, what it is saying is that normally the case is that if the size of the house increasing, the price of the house will increase. So just imagine that if there is a house which is somewhere around 2500 square foot, right? So obviously its price would be quite high, somewhere in this range, right? So this is how we are basically predicting. Like if let's say you bring your test data where the house size is somewhere in the range of 1250, then you should be able to figure out what is my dependent variable. So you'll try to figure out, oh, this the cost of the house might stay somewhere between 200 and 300, maybe around 220. So you are just predicting. This is just prediction. This is not actual, right? Remember, this is just prediction. Perfect. So linear regression. Now again, with this, there are two forms. One is linear regression and there is multiple regression. So first we talk about linear regression. Linear, it's the simplest form of regression and it assumes a linear relationship. So linear relationship means that you are having an input variable and you are having an output variable. And here we have taken an example of linear regression, which is predicting the house price based on the size. So per square feet size, and you're trying to get the size of the price of the house, right? This is linear regression, simplest. Then we talk about multiple regression. Now remember, in linear regression you have only one independent variable, right? But in multiple regression, it involves two or more independent variables, right? And so let's say you have to predict the car price based on the features like age, mileage, brand, engine size. So there are a lot of other features that are being added to it. So that's why we call it multiple regression, right? Which involves two or more independent variables. Then we talk about line of regression. So here, if you see, this is what we call the line of regression. This is the line of regression, and this line of regression can be used to predict the value of y for a given value of x. So whatever algorithm you are using, I just gave you a simple example like y equal to 2x, but remember, this regression line or line of regression helps to predict the value of y for a given value of x. Now you might ask, okay, but what are the applications? So widely used in finance, in stock price prediction, you can do some predictions on what your stock price would be. based on the historical data. Then it can be used in medical diagnosis and forecasting sales in retail based on the historical data and market trends. And yes, as I said, overfitting is an undesirable machine learning behavior which can occur when you don't get accurate predictions for the test data, but you do get it for the training data, right? So quite important that you need to get a balance right. So you need to ensure that the model fits the training data as well as the unseen data or the testing data. And the example it gives is that there is a complex model, right? And the complex model might fit the training data on stock market prices, but fails to predict future prices accurately, right? So again, as I said, it works well on the the training data. When you're doing the training and all, it looks all hunky-dory, very nice. But as soon as you try to bring unseen data, new data, then it starts to fail. This is where you need to tweak your model a bit, right? So remember, this is what we call overfitting problem and underfitting problem, and most of the machine learning algorithms always suffer from this. So you need to tweak or tune your models accordingly, right? And here what I've done is just given a quick example between or difference between regression and classification, just in case you are getting confused. Will it be hot or will it be cold tomorrow? So you are categorizing whether it will be hot, whether it will be cold, right? So you are saying, okay, and based on the data you are getting, you are saying it will be hot or cold. This is classification. Regression, as we said, it predicts a continuous output. So what will be the temperature tomorrow, right? Weather forecasting, you're doing weather forecasting here, and every day or on a continuous basis, you are doing this weather forecasting. That's why we call it regression. So remember, regression analysis predicts a continuous output. You get the value of dependent variable based on one or more independent variables. Thanks for watching.